Good morning. I'm Cody Hendrickson, and we're going to be looking at... Good morning. I'm Cody Hendrickson, and today we're going to be doing a little review of some of the ideas about inheritance and what we can do with it. Specifically, we had a couple things we're going to be looking at today. We're going to be looking at, as a demo for inheritance, we're going to talk about how to use UML, how we can use the super and constructors, as well as how we can talk about interfaces. And so this does go a bit beyond the AP Computer Science subset, but it's well within the Computer Science 1410 course. So if this goes beyond what you're looking at in your home school or what you're working on in your classes, that's great. It's a great resource that you can do and work on that some more. So let's go ahead and let's go take a look at what we're going to be doing with inheritance. So come over here. When we're talking about inheritance, we're looking at how we can actually address the idea of looking at an organization and work with objects in a way we can minimize the code that we have to write and do some cool reuse features and implement things so we can make things work better. So I've designed a quick little basic structure we're going to work with to talk about today. So we have our thingy class right here. Our thingy has a data member of a name and of a universe. And these are both of type string that we're working with. We also have getters that go along with that. We're not going to worry about setters today because that's okay. And then we have a constructor that's a thingy constructor that takes two string parameters. And those string parameters are designed to initialize the name and universe, obviously. And you could have other constructors as you go along from there. But that's the basic structure we're looking at. We also have a couple interfaces we've got collected over here. Again, when we're talking about interface, it's the idea that we have a unimplemented method that we have to implement when we're having a class that works with that. And so we have an oddity interface that has an action that's a void type, a marvel interface that has an attack that's an int type. We have our sci-fi, which has a grab method, our horror interface, which has a spook method, our Potter interface, which has a favorite spell method, it returns a string, and then we have our Disney interface, which turns an is our Disney interface, which has an is princess method, which of course returns a Boolean. So these are the things that we're going to be working with and talking about, and we're going to use some examples so we can demo this. So the first thing we're going to do is we're going to pick up the amazing example of Hey Hey. I know. It's lovely. So we have our Hey Hey object. Now, as we talk about our Hey Hey object, we're going to go ahead and create this right here. And so our Hey Hey object is an inherit from thingy. So we have our UML relationship right here. So we have the Hey Hey class. So public class Hey Hey extends thingy would be what we'd see inside our Java file. And so we have the relationship right here. So we have that relationship with that. So Hey Hey is a thingy. But what's more, Hey Hey is a Disney character. So we're going to go ahead and draw a connection from this for the UML. And for the UML connection for that, I'm going to use a black marker. And for the interface connection, they are generally denoted with a dashed line. So we have Hey Hey is a thingy. Hey Hey also implements the Disney interface. Now, Hey Hey's implementation of the isPrincess method is going to return false. I don't know the gender of Hey Hey, and I don't believe qualifies as a princess status. So Hey Hey does not implement, or does implement the Disney method, but returns false on the isPrincess method. So that's the basic structure right there. Let's take this another example right here. We also have our Katamari Damacy. Okay? And so we have our Katamari Damacy is going to also implement the thingy abstract class. Now, the actual attachment of the arrows themselves don't really matter. We just have to make sure we have an attachment to them, so I can attach from this side, whatever. But it makes it really nice to have a nice little structure with that. So Katamari Damacy is going to extend thingy, so it is a thingy. It has its own universe, and we're going to create that, and we're going to go ahead and grab a connection for that here. And so for the Katamari, we're going to say that implements the sci-fi universe. So we have the Katamari has then the method grab because, yep, it gets to grab it. So the prince gets to grab those components. We can have that right there. So both Katamari and Hey Hey are both thingy type objects because they extend the thingy class. However, Katamari is not a Hey Hey, and Hey Hey definitely is not a Katamari. but they can work together. We can store them together through the power of polymorphism. Now, that's the first thing we want to take a look at. Now let's go do another one. Now, you all remember ZombieHead. ZombieHead has been a fantastic favorite of ours here at CTech. And so we're going to have our ZombieHead object right here. And we'll bring ZombieHead over here. And ZombieHead is a new Java class, just like everything else, and it extends thingy. So we're going to have that relationship go up to there. And so ZombieHead extends thingy. So ZombieHead is a thingy. We've got that right here. It is that. ZombieHead also is going to implement the horror interface. And so ZombieHead has a method now called spook. So this can spook you because, well, why not? So we have ZombieHead, which is a thingy. Hey Hey is a thingy. And Katamari Damacy, also a thingy. So we have that structure that they can have other methods and stuff we define for that, but we know for sure that ZombieHead is going to implement that spook method, and yeah, that kind of ZombieHead, it's spooky. Definitely is going to have something cool happen with that. But that's what we're going to do for that one. So let's do another example here really fast as well. So we have our Hermione Granger and Voldemort figures right here. And so we have a couple examples now of some other classes. So we're going to have a Hermione Granger class. And Hermione Granger is her own object. Hermione Granger is her own object. And we have the Voldemort object right here. I'm just going to write V to save that out. Or we'll do Voldy. Yeah, there we go. Voldy, yeah. So we have Hermione Granger. And so we have Hermione Granger.java, and we have Voldy.java, so that's what we have for our two objects. Hermione Granger and Voldy.java are both over here. They are also both thingies, so they both extend from that. And I just merged the lines together to save some time, so I don't need to draw two extra lines. And additionally, both Hermione Granger and Voldemort implement the Potter interface. So they have a favorite spell. Lord Voldemort, unfortunately, it's Avada Kedavra. I am. And Hermione Granger, well, you've got Alohomora, you've got all sorts of stuff because she's amazing and she knows everything. So they have all sorts of favorite spells that she implements a favorite spell for her. Lord Voldemort, of course, only has one favorite spell because, well, he's kind of boring, but that's who he is. And so we have that in that Potter universe. So we're using some idea of a character like that. So they're both thingies, along with, of course, ZombieHead and Hey Hey and Katamari. So we have these structures right here. We have that reference to it. Let's do a couple more. Debug Ducks. Everybody loves the Debug Ducks. And we've got lots of Debug Ducks. So go ahead and put a Debug Duck over here. And again, they, of course, implement thingy as well because they are Debug Ducks, and that's what they do, is they are there for debugging, so they're definitely a thingy. And for information right here for our interfaces we're working with, well, what does Debug Duck fit in? They're definitely not a Disney princess or a Disney object. They're not from Potterland. They're not for sci-fi. They're not horror. They're not Marvel. They're not oddities. Well, oddities, sure, they've got an action. They can debug. So we'll go ahead and we'll attach that right there. So dot, 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 dot. So we'll say the Debug Ducks have an oddity. Is the implementation, the interface they implement. And that oddity, it means they have an action. Oh, they can help debug. There we go. We've got a reaction right there for this. We've got one more right here. Now, there's how we can show some of the cool effects with this as well. So we have Miles Morales and our great friend Deadpool. And so we have Miles Morales and Deadpool are both examples of Marvel comic book characters. So we have Miles. And we have Deadpool. And so Miles Morales and Deadpool both implement the Marvel interface, and they are both Miles Morales and Deadpool both have a dash line up here to the Marvel interface. They also both have a connection over here to the thingy base class, abstract or otherwise. And so they're both Marvel objects because they fit inside that Marvel thing. And they are both also thingies because they have that. We can also say that, hey, Miles has kind of like a sci-fi approach to him. So, hey, we'll go ahead and give a dash connection to this. Because Miles Morales is kind of sci-fi-ish. Okay, cool, I can fit that. So Miles Morales also has a grab feature. Hey, that works as well, because he has that grabbing. Hey. Yeah. So we've got some great reactions for that. And then, of course, we have Deadpool. Now, Deadpool, being the wonderful human being that he is, well, somewhat, but we can also say that Deadpool, because Marvel also is owned by Disney, that Deadpool implements the Disney interface. And therefore, and he's going to return true on princess because Deadpool definitely considered himself a princess, or themselves a princess, because that's the kind of entity that Deadpool is. And so Deadpool is a Marvel princess, so that would return true on their implementation, as well as would fit inside the Marvel implementation, so we have that right there. So we have a reference right here, so we have multiple interfaces on one class, so we can have that happen. For our last oddity, we have our great friend, the cucumber pickle cactus. They're cute, they're fun, they're wonderful. They are the most amazing tool. They are definitely in the oddity category right here. They're definitely a thingy. They have a name. It's Cactus Pickle. So, Cactus Pickle. Of course, is going to extend the thingy class. And Cactus Pickle implements the oddity interface. And so it has an action. It's pokey. So there we go. So we have some structure with that. So we have a whole bunch of different examples of objects that we can use to talk about the inheritance relationship. Now, although Miles Morales and ZombieHead are not the same kind of thing, they are still in the same category of thing of thingies. So they fit within that broader category. Even though they input different interfaces, ZombieHead guy implements the horror interface, versus Miles Morales implements the Marvel and the sci-fi interfaces. So we have some different structures with that. And so that's what we're working with on the idea of using inheritance, is we have a relationship with that. The next thing we wanted to talk about is how we can talk about the idea of the super/constructors. So the next thing we have inside that. So super/constructors. When we talk about the constructor that we have inside here, over here in thingy, we have the constructor right here. It takes two strings to create the instance of a thingy object. So that means on all these subclasses right here, Deadpool, Miles Morales, Voldy, Granger, Debug Duck, ZombieHead, Hey Hey, and Katamari, all of them have to call super with two parameters as part of their initialization of their constructor. So over here inside heyhey.java, we would have a public, and then Hey Hey. And we can have a default constructor totally fine right here with no parameters. But the first line of this constructor has to be always, it's going to have to be super. And then it's going to have to pass two parameters, a string and a string. So we'll go ahead and we'll pass it a string of Hey Hey. And then a string of Disney. And so by having that first line of super, Hey Hey, Disney, that sends this information up here to the parent class, because constructors are not inherited. I do get to inherit the getters and setters because those are public, but I don't inherit the constructor, but I reference the constructor via the call to super. So super parens, and I pass it the two parameters I want to say for my Hey Hey constructor, and even though there's nothing inside the parameters right here of Hey Hey's constructor, because it's just public Hey Hey, open close parens, it has the ability to call super on that, and it sends it up here. It then initializes the data members of name and universe from the things constructor. The thingy constructor takes care of that. The same thing would happen over here in Katamari. I'd have a public, and I'd have a Katamari. And this one will put a string in here. And so this public Katamari constructor has a string name, and inside it still has to have that first line of a constructor. We're going to pass it super, and we'll pass it the name parameter that's passed to its constructor, and then we'll say it's in the PlayStation or Nintendo. Oh, poo. Katamari Damacy. PlayStation. Yeah. So we'll pass it that PlayStation constructor. Pretty sure it's good. I don't know, honestly. It's okay. I'm screwing up, and it's all good. So, no worries. Okay, so we'll pass it we'll call the super constructor. We pass it the name that's the parameter, because again, if we're ever given a parameter, we want to make sure we use it. And then for its second one, to talk about its universe, we're going to pass it PlayStation, because that's what I decided to use for it. Doesn't matter if that's actually correct, because again, it's just index in the video. And so we have that right there. And so that'd be the first line of its constructor. Now, of course, we can handle any other code we want after that, but that's additional that we can do, not required. But we want to make sure we always call that super constructor. Now, inside these classes, I can make references to any of the public methods because the power of inheritance. So I can have that happen. Now, again, we have one last thing to talk about, is the idea of interfaces. And so Java and interfaces. An interface is a collection of method headers that we want to implement in all of our subclasses that implement that interface. So all these examples right here only have one method because I'm writing this on the board and I'm trying to make a quick demo so we can show this off. But interfaces can have hundreds of methods attached to them, or they can have even 0. When we talked earlier this week about using the serializable interface so we could actually save raw data or binary data to the system, we didn't have any methods when we saved our Pokemon data because serializable has no methods it has to implement as part of it. But when we did our comparable, we did our searching and sorting, when we used that comparable tool, we had to add the compare to method as part of that of type, so we could have it so we could compare it to different objects. But these ones each have one exact each of these interfaces has exactly one method that we have to implement on them. But because, say, for example, right here on Deadpool, because Deadpool implements the Disney interface and the Marvel interface, Deadpool has to have in Deadpool.java a attack method that turns an int and a isPrincess method returns a boolean implemented correctly. Otherwise, it won't compile unless we mark it as abstract. And generally, we're not going to have a class that will do that because if we're implementing interfaces, we want to provide that functionality and make that happen. And so interfaces are a way we can have multiple categories of objects, have them fit in different things. So Miles fits both in the Marvel section and in the sci-fi section. Oddity, when we have our example of our debug duck, Oddity only fits in our debug duck, only fits in the oddity category. Debug duck definitely doesn't fit in Marvel, sci-fi, maybe horror. Debugging can be a horror, but not quite what we're looking for. Definitely not in the Potter universe or Disney, and so debug duck doesn't fit in there. However, if I change that to another duck, starts with a D, maybe Donald. Oh, Donald would fit inside that Disney universe, and Donald would not categorize itself as a Disney princess, so that would return false if it was Donald Duck. But that's the idea that we have. If we're working with that, we have to have that match of the types. And so that's what we're doing when we're talking about the idea of basic inheritance. So we can have something like a zombie head that has no relationship to any of these things, especially a hey-hey. But these are both thingies. And because they're both thingies, I can store them and work them together. I can use that structure right here inside the thingy class. So I can have access to have all the information initialized and used properly. But then thingy doesn't know anything about any of these lovely interfaces because it doesn't need to know that. But ZombieHead does. ZombieHead knows it's spooky. It's a horror interface. Hey, it's a Disney. So I can put the hey in the Disney category. I can do all the stuff with that. And so we have the ability to manipulate and do cool stuff with that by using the power of interfaces. So interfaces allow us to work with that polymorphism to have more types of information with it. Our objects themselves all extend from the parent class. And so they have relationships they can go up to and they use that to have access to it, which means they get access to all the public information via methods. They don't get the private data that's inside the data members, but because they have access to the getters and usually the setters if we have them, they can make any manipulation they need to have inside their subclass as well. Take a look at my other video on inheritance to go a little bit more detail on that. So just a quick review. We talked about how we could do a demo right here with inheritance. We did an example with using the U and L. We talked about how we could use the super reference and how constructors themselves are not inherited. And finally, we talked about interfaces and how we can show the ideas of polymorphism with that. That's a quick little review of what we're working on. We'll add some more information to that. And again, if you have more information, if you need more information, check out some of the other videos and keep on learning. Have a great day, and we'll see you later. Bye.